Chailytics is a highly customizable UI-driven analytics framework. It harnesses modern open-source tools to deliver high-power predictive analytics. As we show in this video here, it enables the analysis to be driven visually via the various UI elements without requiring the user to wade through lines of complex code. A highly scalable cluster as the foundation holds the in-memory datasets and provides the compute power as needed for a very responsive analytics experience. To the left here is the dashboard showing the resource usage by the cluster, the cores, the memory, and the disk space. And up here, it shows the dataset and the algorithm selected for analysis. The Select Dataset tab here shows all the datasets loaded in the memory at this time. And this Load Dataset button allows the user to select any dataset from the directories and select it for loading. It supports many different formats. It could be a CSV, .gzip, or .txt. It could be any format as long as the data is in a proper rectangular table format. Once you select a dataset to analyze, you can easily preview the dataset here. For example, even if it is a rather large dataset, like this one has 13 columns by 125 million rows, but as you would notice, the preview is pretty smooth and quite responsive. You can look at the middle of the file, or you can look near the end of the file, and you can browse the contents of the dataset. You can choose to view all the entries at once, or you can look at smaller chunks. It is just as easy to delete a dataset from the memory if needed. You just select the dataset and click on the delete dataset. It's gone from the memory. After selecting the dataset, you can choose which algorithm you want to run on the dataset. Here, for example, we have shown several algorithms: k-mean clustering, random forest, GLM, which stands for generalized linear modeling, or GBM, gradient boosted machines. You can choose any algorithm to run on the dataset. When you select an algorithm, you would notice that the relevant parameters for the algorithms are shown here for the user to choose. For example, for random forest, number of trees is an important parameter. For k-means, the number of k-means clusters is an important parameter. Also, many other algorithms can be just as easily supported. For example, support vector machines, SVM, or GLRM, generalized low rank models, PCA, many other algorithms can be just as easily supported. After selecting the algorithm, but before we actually run the selected algorithm, the user can select which columns or which factors to include in the modeling and what is the outcome column. Let us take a specific example of running the k-means clustering on this dataset here. This is a dataset containing annual sales for all customers from a chain store retailer with hundreds of stores. All in all, this has about more than 14 million customers. We would like to see how we can utilize the k-means clustering to automatically identify clusters of valuable clients. Let us choose to cluster into 3 groups or three tiers of customers. And let us select our output column based on which we would do this clustering. Let us do the clustering first by sale, the total annual sale. We select the data set, we selected the algorithm, we selected the columns based on which we will do the model, and then let's just run the model. Here it shows that the algorithm is running on selected algorithm is running on the data set. Even though it is a rather large data set of 14 million rows, here it's all done, and it gave us these clusters centered at different values of annual sales.